Okay, have you started the recording? Hello.
Yes, sir.
So in our last class, we were discussing about a special pointer. Hopefully, you all can recall, which is a this pointer, right? So whenever we say if there is a class XYZ, and if you have created an object A, and if that class has got some public member function, say Fn, and if this A calls Fn, from outside, then what we found that internally this gets translated to something like A dot Fn ampersand of A, right? Can you recall this?
Yes, sir.
That means whenever a object invokes a member function, generally public member function, I'm not uh, going into the categorization of the details of it. So then so there are certain member functions for which this is not applicable. So I'm excluding that from the discussion right now. So if it is a public member function, normal member function, then this then the address of that particular object is also passed as an additional argument, even though the programmer has not specified it. That is for sure. And if there is a list of arguments already explicitly defined, so this will be added as the first argument always. As a result, in the body of this also, there will be some change, that this Fn will be able to, so Fn must be able to must have some pointer, because ampersand a means we are passing the address of the object which invokes that member method. So it should have a pointer which is not explicitly written by the programmer, but it is included silently in the background during compilation by the compiler, and this is called THIS, this pointer. And this is a pointer which points to objects of class type XYZ in this case. But another important feature that we have noted is, if I write this plus plus, that means if I try to change what this pointer points to after I have passed this, so this is prohibited, this is not allowed. That means this pointer to that object of this class, this particular pointer, special pointer, this acts as a constant pointer. It's not a pointer variable, rather it's a, you can call it as, it's a pointer constant which is pointing to the object which invoke that member function. So this much we have done. And in fact, whenever we refer to any member within that class member, so generally we write say x equals to x plus 5. This x refers to this member x. So instead of writing this, I can be explicitly writing it like this. Okay. In fact, you may also note that so any such statement that is written will be translated to this form internally. Okay. So these are the internal translations that takes place. So you wrote a simple code in maybe in this blue, but these changes actually take place. Okay.
Sir,
Hmm.
if the index which I've written in the class, if it
Hmm.
is private, Can we access with this pointer?
If it is
If it is
private,
private, I mean access private, then
yes,
can we?
that is possible because you are accessing it within the scope of this class itself. That is possible,
Okay.
but you cannot access that private from here. But you can always access.
Main
So
function.
the entire object space. So this is the say in the stack. This is the space that has been allocated corresponding to the object's members, right? So this entire space, because this THIS is a pointer, so through this pointer you can access it.
Okay, sir.
And where is this? Where from the space for THIS is obtained? What is THIS?
Global.
Why it is global? Where it is defined?
In the class.
So in the class means in the function itself. It's
Oh,
just a function local pointer variable. So whenever the function is called, there is some space for THIS, and through that uh, you are accessing the object space. Okay, just a minute. I have two signatures to just the date বসানো আছে তো? দেখো ওই খামটা নিয়ে যাও, এনভেলপে দিতে হবে, সিল এনভেলপ, সিল করে দিবে। আর এই উপরে ওটা কেটে দিবে, উপরে এটা আছে না, হ্যাঁ, আর উপর লিখে দিবি যে পিএইচডি অ্যাডমিশন রেজাল্টস 2022, হ্যাঁ ঠিক আছে, ডিপার্টমেন্ট অফ সিএসইউ ফোন আর নাম দিয়ে দিবি, ফোন নাম্বার দিয়ে জমা করে দিস কুমো কার্ডে দিয়েতে। হ্যাঁ, সরি, yes, is that part clear?
yes, sir.
So this thing we have already mentioned, and one additional advantage that we get is through this is you can distinguish the difference between, I mean, if you have got a global X and a local X and all this. So THIS, always using THIS, when I refer to X, it will always refer to the member function X, the member method, member data X. Okay, so this is one important feature in C++ as a C++ language, and I think you have followed the modifications that will take place in the background, right? Now we'll talk about one more example, use of this function. So can you follow this code, all of you?
Yes, sir.
Can you just quickly go through the code, what it does? It's a very simple one. Class demo public int x, and then there is a function. So what is this demo? This is a constructor because it has got the name same as that of a class name. It accepts an integer and assigns it to the member function, member method x, the value of n. Okay, and then we have got inc1, increment 1, where it increments the value of x. There is a single member method, member data x. Inc2, where it increments it by 2, and inc3, where it increments it by 3. Is that part clear?
Yes, sir.
And it say for example it returns void in all the cases. So is this part fine? Create an
Yes.
object of class demo with a value 2, and then I write a dot increment 1, a dot increment 2, and a dot increment 3. So what value will be displayed here in the output?
Okay. 8.
So its value will be 8 because it has been initialized to 2, then plus 1 it will be 3 here. After